তো আজকে আমরা আবার সেকেন্ড ইউনিট দেখব কি কি আছে। ওকে, টপিকের নাম হলো অ্যাডভান্সড কংক্রিটিং মেথডস অ্যান্ড ইকুইপমেন্ট। অ্যাডভান্সড কংক্রিটিং মেথডস অ্যান্ড ইকুইপমেন্ট, রাইট? এখানে আমরা কি কি শিখবো এবং ওভারঅল আমরা কি কি পাচ্ছি এই টপিকসে, রাইট? অ্যাবাউট রেডি মিক্স কংক্রিট, the different types of concrete vibrators, underwater concreting, and the different types of special concretes. Ready mix concrete, RMC, one of the most important topics in the civil engineering department or the civil engineering section. What is ready mix concrete? Concrete manufactured in a controlled batching plant and delivered to the construction site in a ready-to-use condition via transit mixers, ensuring consistent quality and mix design accuracy. So ready mix concrete হলো এমন ধরনের কংক্রিট যেগুলো প্লান্টে তৈরি হচ্ছে and as per the desire of the engineers they are being transported to the desired site. Why RMC is necessary? কেন দরকার? Maintains the quality control, maintains the speed of the manufacturing of RMC, reduces the wastage. Okay, no on-site storage. There is no need of storage of RMC in the site. Maintains the consistency and eco-friendly, environmental friendly. Does not produce any much pollution, does not produce dust and pollution at the site. RMC plant, its equipments and products. Okay, so this is the total process flow of a RMC plant. First is the assembling of raw materials. Okay, then we have to assemble by the batcher. Okay, it's done basically by wave batching. Then comes the central mixer where the total aggregates and all the materials including cement and water are being mixed thoroughly. Next comes the transit mixer. So transit mixer কি করে, যে মিক্সারটা যে মিক্স আমরা প্ল্যান্টে রেডি করছি সেটা সাইটে, রেফার্ড সাইটে বা ডিজায়ার সাইটে নিয়ে যায়। যে কংক্রিটটা তৈরি হলো সেই কংক্রিটটাকে রেডি মিক্স স্টেটে সাইটে ডেলিভার করে থ্রু ট্রানজিট মিক্সার, অ্যান্ড লাস্ট কামস দ্য সাইট ডেলিভারি। ওকে, সো কি ইকুইপমেন্টস ইন আরএমসি প্লান্ট? Wave batching system, as already I said, pan drum mixer where the mixing is being done in the manufacturing process of concrete. Transit mixer, এটা আমি আগেও বললাম, which transfers the ready-made concrete from the plant to the desired site, and the concrete pump which actually delivers the RMC to the desired site. Okay, so then comes the concrete pump which is actually used to place the fresh ready mix concrete to the site. Now I will come to one of the most important topic of this unit, underwater concreting. We have seen different types of construction underwater also. So how does that happen? Underwater construction, underwater concreting are very much important in today's era. Okay, so key challenges, what are the challenges we face, right? Cement washout, segregation, water infiltration, no vibration, poor inspection, and the progress is ultimately slow. So all these are the challenges faced in the underwater concreting process. So already I have told you that underwater concreting is nothing but the concreting in the water filled or submerged conditions for structures like bridges, piers, piling caps, dam foundation, marine structures and quay walls. So this is one of the most important method of underwater concreting. It's called the tree method. So this is the step-by-step procedure. Okay. So first we will lower the tree pipe to the foundation level. Second, we will seal the bottom with the plug or wall. Then we will fill the hopper with concrete and then begin the continuous pouring of the fresh concrete. Then we will raise the pipe gradually and continue till the completion. So this is the tree method schematic structure, right? You can see here, this is the hopper. This is a pipe of 250 to 300 mm dia. This is the water level and bottom is the concrete. Okay. So some special concretes. Okay. High strength concrete, high performance concrete, roller compacted concrete, self compacting concrete, steel fiber reinforcement concrete, foam concrete, guillotine and short treating. Okay. See, high strength concrete with compressive strength greater than 60 MPa. Achieved by extremely low water-cement ratio, quality aggregates and chemical admixtures. So by maintaining all these criteria, we will be able to achieve high strength concrete. So already I told you this is the scenario of how high strength concrete is being achieved. Maintaining low water-cement ratio using admixture like super plasticizer and silica fume and also using high quality aggregates. So this is a comparison chart of different concrete grades, right? You can see here the water cement ratio, the admixtures, so all are being categorized, right? High performance concrete, it is designed basically for superior performance strength, durability and workability simultaneously, not just strength, okay, also defined by the American Concrete Institute 363, ACI 363 as concrete meeting special performance requirements not always achievable with conventional mixes. So 3 pillars of high performance concrete: high strength, high durability and high workability. These are the main points and the main criteria for maintaining the high performance concrete. So what is the difference between high performance and high strength? High strength mainly focuses on the compressive strength, and in case of high performance it is broader. So high performance mix may or may not be high strength, but it should meet the specific performance criteria for its intended application. For example, an HPC for a marine beach pier must resist chloride penetration and corrosion even if its characteristic strength is 45 MPa. Next comes the roller compacted concrete, having zero slump, very dry. Okay, so this is the procedure. You can see mixed production, transporting and spreading, then total spreading with the help of bulldozers, and then compacting and then curing, pouring water for the desired strength, right? So some key properties and applications you can see here. Property, typical value and application. Now here comes the self-compacting concrete. It flows and consolidates under its own weight without any mechanical compaction. So it doesn't need any compaction process, right? So the 3 key fresh properties of self-compacting concrete: filling ability, passing ability and segregation resistance, right? Mix design and its applications also is very much important. Next comes the skin fiber reinforced concrete. Concrete reinforced with randomly distributed short steel fibers. So we will be able to see some steel fibers in the concrete, which together forms the steel fiber reinforcement concrete. It prevents the cracks and also improves the or maintain the tensile and frictional resistance. Okay. So you can see here how fibers improve performance, tensile strength, flexural strength, impact resistance and fatigue resistance and shrinkage cracking. Right? See, foam concrete is also very important, very light in weight, basically made with light weight aggregates. Production methods are basically pre-formed method and mixed foaming method. So properties versus application, you can see the differentiation between the different parameters: density, compressive strength, thermal conductivity and application uses, right? Guillotine is applied at high velocity using pneumatic pressure. Water is added at the nozzle and also called the dry process shotcrete. Okay, one of the most important process. So this is the total process flowchart of guillotine, right? And these are its specifications and applications where all the criteria is being maintained. Shotcreting. Okay, shotcrete is concrete pneumatically applied at high velocity on the surface. It can be a dry process or wet. So this shotcreting can be dry or can be wet. Okay, and used for permanent structural application, including tunnels and slopes. So dry process versus wet process shotcrete procedure. You can see here. These are the different aspects. These are the parameters with respect to the aspects and in dry process, and these are the parameters with respect to wet process. Okay. Applications you can see: industry, tunnel construction and lining, rock slope stabilization and swimming pool construction also, and repair of damaged concrete structure. Advantages means it doesn't need any formwork, can be applied on any surface, irregular or curved. Excellent bond to existing concrete and rock. So this is the master comparison chart, okay, of all the different types of special concrete. You can see the water cement ratio here. You can see the strength range of all the different sizes of concrete, and you can also see the primary application of these. And these are the real world industry applications, okay, in high-rise buildings, bridge spire foundation, gravity or RCC dams, tunnel construction, one of the most important construction, precast factory and structural repair and rehabilitation. So what do we learn here? These are the important takeaways of this unit. What we learned from this unit.